All right, so now we're gonna focus on how we create and talk about scatter plots. So remember, in many studies, the goal is basically to figure out what one variable does to the other. So which one, actually causes changes in the other variable, So which one's the response variable and which one's the explanatory variable. Now, it's not always going to be so clear, and it's not always going to be that one variable causes changes in the other. Sometimes they're just what we call correlated or associated, and we're going to talk more about this later. So we want to see, a visual of what's going on because that's going to let us more clearly determine if there's really a linear relationship between the variables. And again, we'll talk about that more in the next couple of lessons. Now, again, we like to use scatter plots for, representing relationships dealing with two quantitative variables. So when we make a scatter plot, we have a general technique or, general, guidelines for talking about them. We want to basically look for the overall pattern and for any striking departures or any, abnormalities from that pattern. So we will focus on the direction of the pattern, the form of the pattern, and the strength of the pattern. And again, we'll talk more about how we address each of these characteristics. So in other words, we don't really care about little things. We have to look at the overall picture, the big picture of the relationship. Also, we need to make sure we address any outliers or any, points that look like they're, not going with the general trend. Think of an outlier, as like an outcast, something that doesn't follow the rest of the guys. And so a way to remember what you have to address is by using the acronym I like to say DOFS. So direction, outliers, form, strength, direction, outliers. I don't know why I wrote it this way. Form and strength. Really make sure you memorize this and keep this in mind because on your AP exam, they look for these 4 attributes. They actually grade you strictly on this. So this is a big deal. So let's look at what else we have to remember. So in general, when we're talking about, how the variables, are associated, we like to, talk about whether they're positively associated or negatively associated. So just like what you would think, intuitively, when they're positively associated, when one value increases, the other value increases. So when X increases, Y values increases. When they're negatively associated, when X increases, Y decreases, or when Y increases, X decreases. So we like to say above average values and below average values tend to occur together. But don't overthink this again, it's just what you would intuitively think. So let's go ahead, let's actually do one. Let's create a scatter plot. I would always recommend doing practice problems. That's the best way to learn math. So let's go ahead, let's look at this scenario here. So track and field. So we got each member of a small stats class ran a 40-yard sprint and did a long jump with a running start. The table below shows a sprint time in seconds and a long jump distance in inches. We're going to make a scatter plot of the relationship between sprint time and long jump distance, and then we're going to describe it. Okay, so again, when you're making a scatter plot, figure out which variable is going to be the explanatory variable and which one will be response. The explanatory variable will, be like your X, or will go on the horizontal axis. The response will be like the Y, which will, be the vertical axis. And again, you just have to think about what would happen in real life. So here we have sprint time versus long jump distance. So it's going to be likely that sprint time will be our explanatory variable. Because we would basically say that this is what, is responsible or what causes you to, be a longer jumper, be able to jump farther. The faster you are, the longer you tend to jump. Now, yeah, I guess you could say that the longer you tend to jump, the faster you are. But again, just think of real life. Like, you're probably gonna, use sprint and power training to increase your long jump distance. You're probably not gonna be doing long jump distance to increase your sprint time because you would have to run and vice versa. But again, It's just what you would, what would make sense in real life. There's not like a formal black and white rule. Okay, so let's have sprint time on the horizontal axis and make sure you indicate units of sprint time in seconds. And I'm gonna go by, let's start at 5. And then go by 0.25, just measuring every 0.5. So use what would make the best sense. And then long jump distance in inches up here. And again, we're gonna do it in inches, so make sure you address the units. Now I'm just gonna start at 50 and go by tens. And then we just plot them as best we can. 5.41 is our x, and these are our y's. So 5.41 and comma 171, so 5.41, somewhere around here. 171, probably like over here. 5.05, 184. Really close to here, probably like up here. I'm gonna go ahead and time travel, so go ahead and pause the video, and when you got your scatter plot done, you can go ahead and unpause it. Okay, so your scatter plot should look something like this. So when we describe a relationship, we need to make sure we address the direction, any outliers, strength, and form. And we kind of put it in the context. And for now, again, we haven't learned too much about, what it means, what levels of, what the forms could be, what the strengths could be, all that. So we're gonna use like a basically a loose, description. So what we can say is that, the direction is negative. There appears to be like a negative association between the variables. The relationship appears to be, not super strong, but not weak. So we can say like medium. And for now, like at least in this chapter, we're either going to say the relationship is linear or non-linear. And we're going to basically just go with the one that we think is more likely. So we would say something like, there appears to be a moderate negative linear association between sprint time and long jump distance. Between sprint time and long jump. And if there doesn't seem to be any outliers or any obvious outliers, just say that. So we'll just say with no obvious outliers. So see, I mentioned the strength here. I got my S, the direction, the D, the form, linear, and outliers. And I got my DOFs. This is important because again, on your AP exam, they need you to address these 4 characteristics to get full credit. And you want to mention them in context. Don't just say moderate, negative, linear, outliers, and like a checklist. Explain it in context so you can demonstrate to the reader that you understand the scenario and how these are how these relate to what's going on in the problem. So I usually like to have a general sentence form that I'll use with my students. So if you want, you can use something like this where you're always just mentioning the relationship in this sort of way.